In this segment, we are going to be looking at something called a multiplexer. A multiplexer is just another combinational circuit which is let's say one notch higher than your normal adders and subtractors. So what happens here, again like any combinational circuit, is you give it some inputs, something happens in the circuitry here and you get some outputs. But apart from the inputs and outputs, you have something called the selection lines. So basically what happens is you have a number of inputs in a multiplexer and only one output, and the output is just one of the inputs. So in your adders and subtractors, you took the inputs and you performed some operation on them and then you displayed the result. But in a multiplexer, we're not going to be doing any of that. We'll just take one of the inputs and display them directly as the output. But which of those inputs do we select? Let's say I have 8 inputs. Which of them am I going to select? Which of the 8 is going to be my output? So to decide that, we have something called the selection lines which help us select one of the inputs. So we'll take a closer look at how this works. So in a multiplexer, we usually have 2 to the power n inputs, n selection lines and 1 output. These n selection lines can be used to generate 2 to the power n combinations, and each combination represents one input. So what do I mean by this? Let's say I have 4 inputs and 2 selection lines. Now my inputs and my selection lines are all binary variables. They can all take the values 0 or 1. So again, 4 inputs, 2 selection lines. So what are the combinations of values my selection lines can take? They can take 0, 0, 0, 1, 1, 0 and 1, 1. And each of these represents one input. Let's say 0, 0 represents I0, 0, 1 represents I1, 1, 0 represents I2 and 1, 1 represents I3. This is an arbitrary assignment which we are making. Now, if my selection lines are in the combination 1, 0, then whatever value I am giving as input I2 is what will get reflected in my output. If they are in the combination 0, 0, then whatever value I am giving for I0 is what is going to be reflected in my output, and so on and so forth. This is what I mean when I say the n selection lines can be used to generate 2 power n combinations, and each combination represents one input. So that's what is written here. And this multiplexer is generally used to implement Boolean functions. How is that done? We'll be looking at it in more detail in a future segment. But a basic overview of multiplexer is 2 power n inputs, n selection lines, one output. The output is simply one of the inputs. There's no arithmetic operation done on it. And how to select one input from the 2 power n? We have n selection lines which can be used to generate 2 power n combinations. Each combination represents one input. So depending upon what is the actual combination of values my selection lines are taking at a given instant, the corresponding input is what gets mapped to my output. This is a broad overview of how a multiplexer works. So we now take an example of a 4x1 multiplexer and we'll see how the circuit diagram goes. So in a 4x1 multiplexer, we have 4 inputs which we are going to call I0, I1, I2 and I3, 2 selection lines S0, S1 and one output Y. So these are your I0, I1, I2, I3, your S0 and S1, and I also added S0 complement and S1 complement. Now we'll see how this works. So we'll first draw the truth table somewhere here. So we have S0, S1 and the output Y. So the Y is going to depend upon our combination of S0 and S1, right? So S0, S1 can take these 4 possible combinations. So if it is 0, 0, my Y is going to be equal to I0, 0, 1 it is I1, 0, 2 I2, 0, 3 I3. So this is going to be my thing. And when I0 is being reflected in the output, everything else must be 0. We'll see how that works. For now, coming back here, so when S0 and S1 are both 0, I want my output to be I0, right? So you consider the expression S0 complement and S1 complement and I0. What will it be? When S0, S1 both are 0, S naught complement and S1 complement and I naught is going to be equal to I naught, right? And for any other combination of S naught S1, the expression is going to be a 0. Similarly, we come up with expressions for each of these. For example, if my S naught S1 are 0, 1, then my output has to be an I1. So, if I take the expression S naught complement S1 I1, then we will see that for the given combination 0, 1, this term will give me an output of I1, and for any other combination it will give me a 0. So when we look at the figure, we will be able to understand better. So we start with S naught dash S1 dash I naught, S naught dash S1 dash I naught. You put everything to an AND gate. So this is your S naught dash S1 dash I naught. So if you're not able to make sense of this at this point, I would encourage you to pause the video and to draw truth table for S naught dash S1 dash I naught. You list all the 8 possible combinations of S naught S1 I naught and see what values you're getting for this term. You will notice that when S naught S1 are 0, your output will exactly be what I naught is, and in all other cases it will be a 0. Similarly, for S1 the corresponding expression is S naught dash S1 I1. How do you identify? You're simply replacing the zeros and ones in this expression with the complement and the term respectively. Meaning, if it's a 0, 0, it's S naught dash S1 dash. If it's a 0, 1, it's an S naught dash S1. 1, 0 will be S naught S1 dash, and 1, 1 will be S naught S1. So why does this work? Because for those corresponding values, when you put them through AND gates, it will give you exactly what I you wanted, and for any other value, at least one of the selection lines is going to become a 0. As in, for example, here we took this case S naught dash S1 dash I naught, and at 0, 0 I naught, this will be 0 complement 1, 0 complement 1 I naught. So the final output is going to be an I naught. But you take any other combination 1, 0, 0, 1 or 1, 1, one of these terms becomes a 0. So your final output from this line will be a 0. And that is how it will work for all other cases also, provided you choose the expressions in the right way. So for I1, what is it going to be? S naught dash S1 I1. This is 1. So this will give me a 1 in case I have this combination of S naught S1. For any other combination, it will give me a 0. Similarly, for I2, we have S naught S1 dash I2. So this is our S naught S1 dash I2. And for I3, it is S naught S1 I3. S naught S1, and here is I3. So we have these 4 AND gates. Each of these gates will give me a 1 if the selection lines are set to this corresponding combination. Each of these gates will give me the respective input value reflected back if the selection lines are set to the corresponding combination. For any other combination, they'll give me a 0. And my final output is just going to be that respective term, right? So if my selection lines are set to 0, 0, I want I naught to be the output and nothing else. And here I have designed a circuit such that if my selection lines are set to 0, 0, this will give me I naught, and all these 3 are going to give me 0. Similarly for all other combinations. So what we do is we just connect all of these using an OR gate. You connect it to an OR gate and you specify that the output is Y. Now why does this make sense, and what did we do here? We took our 4 inputs and 2 selection lines. We also took the complements of the selection lines. We listed the truth table to identify which of the inputs should be the output for every combination of selection lines. Then we set up 4 AND gates such that for every combination of selection lines, that respective input will be given as output by one of these gates, and the other 3 gates will give me zeros. Now if I connect all of these using an OR gate, it means for every combination, one of these is going to give me a specific input. Let's say if my selection lines are 0, 0, this one is going to give me an I0, and all other 3 are going to be 0. So I0 or 0 or 0 or 0 will be I0. So when my selection lines are 0, 0, I0 is what I am getting back as output Y. Similarly, if my selection lines are 0, 1, this one will give me the output I1 and all others will be 0. You put everything through an OR gate, you will get back I1. And similarly for the other 2 cases. So this is how we construct an n cross 2 power n cross 1 multiplexer. So the only catch here is identifying this equation or this expression, right? How do you do it? You just take this truth table, and wherever you have 0, you replace it by the complement of that selection line. Wherever you have a 1, you just put that selection line right there. So what would be the expression for this? I would invite you to pause and frame the expressions for these 3 first and then check. This one will be S0 dash S1 I1. S0 dash S1 I1. This will be this one will be S0 S1 dash I2. S0 S1 dash I2. This will simply be S0 S1 I3. So this is how a multiplexer works.